Okay, so thank you for attending today's meeting on deployment patterns for AUTOSAR technology. So we thought it might be interesting or useful because everybody is talking about use cases in the SDV context and how technologies are applied, talking about building blocks. And we also from the AUTOSAR perspective thought about this topic. And therefore, I wanted to introduce in this talk so-called deployment patterns. And by the way, I wouldn't mind if you just ask questions directly as soon as they pop up. If this is no problem for anybody else, it should be fine for me. Okay.
So,
Yeah. Hi, Mario. Just start with the introduction.
Yes.
So I'm ready to go.
Okay. So then, hello and welcome. Sorry for this. Yeah, checked really 3 times that I copied the right link to all this, because in the first TechTalk there was the same issue. Second one it works, but now it seems there's still something going wrong. But I think now people are here, and not so much words. Welcome to this TechTalk, the open TechTalk from the SDVoF community organized by FEDERATE. So today you see deployment patterns for AUTOSAR technologies, and for that I will hand over to you, Eduard, so that we can start.
Thank you very much. Mario, is it okay if people ask directly, or should they put questions?
It's on you how to handle that, so they can ask or raise hands.
They can ask directly if they like.
Okay, great.
So get started. So what are actually AUTOSAR deployment patterns, and why AUTOSAR thought they might be needed? So we had, as an AUTOSAR body, a request to AUTOSAR from partners and also third parties. So partners are basically AUTOSAR members, and third parties are other consortia, for example, or open source communities. And they requested, a little bit from us to show some kind of technology leadership, to show our understanding. And especially partners sometimes have system and software architecture design questions. They are not basically talking a lot about single stack components so much. So whether to use that component or that component in a stack, but rather have overarching questions that often even range from the HPC to the sensor level. How AUTOSAR can be used to realize some use cases. And also these patterns serve us and also the community to show how AUTOSAR technologies can coexist with different software ecosystems. So whether you think about something like Covesa's VISS and VSS approaches, or if you think about other OSs like Android, for example, those, or for example, if you think about others use cases where you have different ecosystems provided by chip vendors, so they can also contribute to show how these systems or ecosystems coexist. So our approach was to, together with our partners, develop so-called deployment patterns. And they help to understand what role AUTOSAR adaptive platform and AUTOSAR classic platform technologies contribute. So to those that are not familiar, so AUTOSAR adaptive is AUTOSAR's microprocessor software platform, and classic platform is towards microcontrollers. The benefits to us, and this is probably similar to the building blocks in the Eclipse SDV ecosystem, is that they help to identify gaps and also our system boundaries. So where does AUTOSAR stop and other ecosystems pick up, where we might have gaps, and also to understand better our interfaces that we have to other ecosystems like Covesa, SOFI, Eclipse, and so on. And last but not least, also, of course, to communicate the benefits of the AUTOSAR ecosystem. That's also, of course, the purpose. And we try to have a so currently everything as text is very on vogue, and MD files. We went a little bit different direction to try to communicate as visually and as close to the scenarios of our partners and also third parties as possible. So therefore the idea of so-called deployment patterns. And as I said, they are quite visual, these patterns. And what we needed was an illustrative example of a vehicle EE architecture. However, this is just, as I said, an illustrative example. So we don't require this this architecture. We see that some companies are going in this direction, but I think it's still some time until everybody picked up with some architecture like this. And maybe it doesn't even make sense for everybody. But as I said, it's just a framework for the architecture. Any question? I don't see raised hands, but there are some. Okay, so what does these blocks mean? So we have this simple sensors actuators like light, rain, headlight, trailer. And these are typically, we see them as anchored on a microcontroller. And there also on this level, we raised the question if there's probably room for an ecosystem, especially to these smaller controllers where the full AUTOSAR ecosystem might be, let's say, too heavy. So probably you might not need an RTE on the simple sensors actuators. You might not need a full-blown OS, and a lot of other simplifications can be made on this level. Then what we see in such architectures are complex sensors actuators like radar, LIDAR, camera. There we see that there are currently various solutions and OSs also provided. For example, by the ADAS system vendors, there are solutions, but also by camera vendors and vendors of such subsystems. So there currently AUTOSAR has not a very specific use case, maybe just to provide coupling to transport raw data. Then the home ground for AUTOSAR-based systems is typically the control, where we have systems like powertrains, battery, chassis. This is currently still the field where AUTOSAR Classic platform is used a lot, together with OS and all the communication and other features. Then on the zonal controller, what we see currently as the partners is that there are still some, let's say, fights are going on, or basically some concept work going on, what's actually the role of the zonal, and also what technologies are used. Is this really a pure field for microcontrollers, or is there also microprocessors used on zonals? Are there just routing signals from the outer ECUs to the HPCs? Do they do some kind of abstraction job? Do they do aggregation of functions which were previously on smaller ECUs? So it could be actually a mix of different technologies on the zonal. And then there are what we call HPCs, so these central computes, which are typically have some kind of POSIX style OS, hosted on a SoC or microprocessor. And also there we see that the POSIX OS and adaptive platform can play a bigger role, but also some microcontrollers on these ECUs, still classic, can play a role, but it's typically dominated by service-oriented communication. And at the back end, of course, so the car is connected, of course, as everybody knows, to the back end. There the question is, okay, Is there something like an automotive API to couple those? What role does containerization play, microservices? So these are topics which can be discussed with relation to the backend. And one example, as I said, when I introduced the talk, I want to introduce 3 patterns to give you an impression what patterns are about. So the first pattern I want to present is basically a pattern which is about accessing vehicle data, for example, as a catalog from the cloud. And this pattern has a short name, Automotive API. And so the scope of this pattern is, however, not only the cloud and the HPC, but also extends on the zonals and even, let's say, smaller kind of ECUs. And why this is the case, this is I explain this when we look at the details of this pattern. But questions that are raised here is how actually is the vehicle connected to the cloud? Where is the abstraction done? So abstraction from all the hardware related stuff and the vehicle topology. And how do we get access to data which is available on small ECUs, which are typically not running any, let's say, smart protocols to provide their data to any cloud services. And here you see a snapshot how the technical side of this pattern looks like. So you see we have here in the big gray box the cloud part of the pattern, where some kind of cloud application accesses or wants to access vehicle data. It uses then what we call the automotive API, probably some kind of cloud middleware, and then via VISS, for example, over MQTT, can communicate with an IVI HPC. And on this, you can have, for example, an Android partition. You can have an AUTOSAR adaptive partition. Both of them can implement the automotive API. And what we have here in addition is what we call a VISS SumIP gateway. And this is able to expose basically elements which are defined in the VSS catalog to someone who wants to access them via the VISS protocol. And other questions like, okay, how is this protocol, or how is this catalog getting its data? So there's, of course, all the data which is already available at the HPC can be quite easily, of course, pushed in a catalog, which is then provided via VISS. But what if you need, for example, data from a very simple sensor actuator, which is one of the blue box? It probably don't has even an RTE, maybe just a diagnostic port, CAN module and M cards, and is providing its data via the CAN stack. And there, technologies can come into place, like that you have some basically core on a zonal controller running signal to service mapping, where such a CAN signal is then translated basically to a service, maybe enriched also with other data, and then provided to the gateway so that it can then be exposed to the clouds. And yeah.
May I ask one question, Eduard?
Yeah, sure.
Is it planned that this VSS catalog is then, or should be part of AUTOSAR specification or integrated, or? So
what we have defined, or what in the concept that is currently or released this year, 2511, AUTOSAR is on the one side specifying this VISS SumIP gateway, and on the other side a methodology how you can translate the VSS catalog that you are using into an AUTOSAR model that you can use for your gateway. So these are the basically, so this VSS is an open standard that you can edit with any open source tool that you like from the VSS community. And then we are a methodology and tooling approach. You can transform those parts which are required by the gateway to an RXML.
But then it's planned to harmonize both, so to integrate that in AUTOSAR, so that these AUTOSAR XML files are aligned with this VSS.
Yeah,
so
it's
that
more
everything is generated.
It's a generated approach. So the VSS is used to generate the required AUTOSAR XML part, which you need. But so this was elaborated together with Covesa. So we gave also some feedback to the VSS catalog, for example, about signals and which we think would be useful. So it was a little bit a two-way direction in this project.
Thanks.
Okay. So the next pattern is about safe and high performance data feed for others. So there the question or the point is that you often have already an other software ecosystem, for example, provided by NVIDIA or other vendors which are strong in this market. However, they typically stop at the point where you need access to the vehicle data that is then fed into all these algorithms that are required for other systems. So on the one side, again, of course, it's closely related, this pattern, to the actual others HPC. But as you need data also from other areas, also the wider range around, including zonals, plays a role to determine, okay, which technologies need to be used. Again, here questions do pop up. So where's the actual abstraction happening on the HPC or on the zonal? And frankly speaking, we have seen multiple approaches. So some people say the abstraction should happen on the HPC. However, this brings a lot of hardware dependencies to the HPC. And everything needs to be routed to the HPC in the end. But doing this on the zonal also brings questions up like performance. So we've basically seen both approaches. And also the questions also pops up how to ensure functional safety in such a setting. So with these patterns, we dive a little bit deeper again in the stacks. And what you see here is the yellow part is the HPC stack. The green is the zonal part, and then again you have the sensors and actuators. And where we see, for example, the role of AUTOSAR technologies is that you have typically functional safety islands on such an HPC, which help to ensure the safety of the others software. So there typically also the high performance requirements of Classic are required. Then on such a HPCs, you often find smart switches. There we, at least as a company, are employing AUTOSAR Classic on the smart switches, for example, to control the firewalls of such a switch. And then again, to enable fast forwarding of data, the multi-core capabilities are an important factor. And again, signal to service can play a role in feeding data which might be only available on CAN, for example, in services to the HPC. And then One thing that is typically, so beyond this legacy communication data feed role that AUTOSAR has, which the solutions like Android or solutions like NVIDIA's don't really detail out this legacy data feed. So beyond this, typically diagnostics is also a topic, and logging is a use case which you can use adaptive technology. Okay, and finally, so the pattern that is also discussed is in the area of cybersecurity, how to enable defense in depth of vehicle assets. So, for example, how to ensure the integrity of the ECU software, how to ensure freshness and integrity of the communication, how to detect and then report intrusion attempts. So these are questions which require an overarching answer. And there we see technologies like authenticated diagnostic access, for example, where you can, for example, use certificate chains for diagnostic access. There's an AUTOSAR component which is called the Intrusion Detection Manager, which you can deploy on zonals or end nodes, and then can be used to report so-called security events over the bus by using the IDS protocol. And by the way, the IDS protocol is opened, so that there's no you don't have any costs if this protocol is exploited and used and implemented. And the same is for the security events which are specified by AUTOSAR. They can also be used by anyone. The structure is defined, but of course, also any kind of additional security events can be specified. Then AUTOSAR provides firewall specifications for the HPCs and also for Classic. The hardware accelerated crypto primitives play an important role if you need speed, for example, if you want to do a secure onboard communication. So the crypto stack needs to provide accelerated crypto primitives. Secure boot can be, of course, established. There, in the meantime, also AUTOSAR-based HSM firmware is available on the market. Again, similar to the usage scenario on the switch. It's not a full AUTOSAR stack, which is used on the HSM, but a reduced one to handle the needs of the secure core. And then there are concepts around like secure onboard communications, which have been around for a long time to ensure freshness of and integrity of onboard messages. Yeah, so this is, as I said, another pattern, or the third pattern, where we try to not just, let's say, enumerate technologies or building blocks, but try to give it a little bit more visualize it, where it's actually anchored, where it can be deployed. So this was an intention to also share this information with communities and also under other standardization bodies like, as I said, Covesa and others, to get a better understanding which elements are there to and can be used from the AUTOSAR ecosystem. So we have a number of other patterns in the working. So one topic is also orchestration and containerization of automotive software. So which methods, methodologies, properties AUTOSAR has to introduce to better support this. Then it's possible now is one of them, but also how AUTOSAR fits into an IVI scenario. There I see, for example, also that it's primarily a data feed to something like Android Automotive OS and providing this very automotive specific layers like automotive specific communication protocols, diagnostics, network management. So things that are typically not available in those frameworks like Android or other ecosystems. Okay, if you're an AUTOSAR partner or not an AUTOSAR partner, if you have pressing questions, if you're a member of other ecosystems like, I don't know, Eclipse SDV or any research projects and have system design challenges which should be addressed, you can definitely reach out also and discuss your ideas with the AUTOSAR organization. So this is definitely welcome. And the slides were also presented on an AUTOSAR open conference, which is anyway open to anybody, also to non-AUTOSAR members. And therefore, it's also possible to share those slides that I showed you. Okay, so this is, as I said, part of a bigger slide set, but this part is completed. If there are any questions, feel free to ask.
So these deployment patterns here in this Excel sheet, so they are planned or they are in the concept phase or they are still prepared?
So we are working on this, or actually these are quite far, the HPC full stack for cloud native development is almost finished. And actually we put 6.1 and 6.2 together into one pattern. So we organize them into one pattern. And the other ones are more in discussion. So for example, vehicle to X end-to-end, we did basically, so this is a list of suggested patterns, but there we got very weak feedback from partners. And so there we had the impression that this vehicle to X topic is not so much anymore a topic which is tackled in AUTOSAR and in AUTOSAR standardization actually. And therefore this is not a very high priority for us.
Okay. But finished means in that case there's a specification out there or a document, or is it implemented somewhere?
So the patterns which I mentioned before, those elements are all implemented. So in terms of specifications and typically except the automotive API, which is just released this year, the other patterns are available typically by the stack vendor that you choose. So this is not a lot about future technologies, but more about what's currently already available in terms of components and how it's more to communicate how those components are deployed and used to solve some basically design questions. Okay. So the actual specifications are already done. What these patterns are just about is better explain, because if you have all these individual specifications, so you have one on a crypto stack, you have one on maybe signal to service, you have one on multi-core, you don't have a good understanding how they fit together to solve certain design problems. And so these patterns are more a means of communication.
Yeah. See.
So, Edward, I have 2 questions. One is the deployment patterns; those are on the screen. They are. How is the information available about them? Because I mean, orchestration and containerization itself is quite a topic that requires explanation. So, if somebody is interested in that, how he get that information?
Well, how we until now worked on is basically that in AUTOSAR there's a so-called architecture working group, and there's also a working group of all the core partners, I would say. So we collected all these patterns, then discussed it with our architecture group, and some of those patterns we now published, for example, like here or at our conference. So currently, yeah, it's limited to AUTOSAR partners to get really detailed access.
Okay.
Not sure if you are an AUTOSAR partner.
Yes, I am.
Yeah. So then, for example, if you are involved in the architecture group, we also presented this on the all working group meeting. Yeah, we try to publish a little bit. Yeah.
Okay, and the last one is about this data feed for ADAS. So maybe if you go back, then the slide that is afterwards. So what is really the patron is about? I mean, we don't have sensor interfaces yet, as far I know, in AUTOSAR.
Yeah, it's not about sensor interfaces. It's more that so typically solutions like NVIDIA's ADAS software, they want for a good reason to abstract their functions and services at a quite higher layer, and therefore they don't deal a lot with how the signals and all the data comes into the ADAS layer, and there AUTOSAR just plays the role of really getting the data into the into the lower layers of the ADAS stack, and then of course you still need to do implementation to bring it in the end form of what you actually need in your other solution.
So irrespective of the vendor of the sensors, so the interfaces or the data, the frames would be available.
Yeah. There's also an abstraction of the ADAS implementation towards the app. It has been introduced in AUTOSAR, but frankly speaking, I have also asked colleagues about it, and they say that they haven't seen it in use in projects.
Thank you. Additional questions from the audience? If not, maybe I have one more question about this cybersecurity. So that's still, so the whole security is behind the perimeter or behind the firewall or whatever. Is it planned also to go in this direction to have some data-centric security so that the data are encrypted, so there is an owner, valid for whatever?
Well, I think as soon as you send the data outside to the cloud, I think their encryption does come into play. But on board, we so far have only seen the need to really maintain integrity and ensure integrity. So onboard encryption, we don't have seen so much.
Okay.
Still a multi-layered approach. So this security event detection, for example, you can have it even on your small ECUs, and then report events to the HPC and then send it to the cloud. So this is one option that is quite flexible to deploy on HPC zonals or ECUs. Yeah. But I think from a terms of openness to other communities, I see also the standardized automotive security events and their structure probably could be interesting. I don't know if people interested in security are in the call, but that might be something because there's no restriction on. It's meant to be open.
Okay. Thank you.
You're welcome.
Other questions from the audience? If not, then I say thank you a lot, Eduard. The great presentation, the explanations. Sorry for the complications at the beginning. So it seems we need another approach to send out these invitations to several projects. But yeah, we'll find a solution for that.
No
so
worries.
the video is recorded, so I will inform you if you have missed the beginning, let's say, so they can watch it on YouTube. Okay. So then thank you very much for joining, and hopefully we see and hear us in the next Open Tech Talk we organize.
Yeah, have a nice day.
Have a nice day. Thank you. Bye.
Bye.
Thank you.
Bye-bye.
Thank you.
Bye-bye.
Bye.